Many don't like containerized package managers. I do. Hello, my name is Primoz aka Bigpot, and today let's talk about containerized package managers and why they're good, not bad. Linux itself has been in many ways evolving since its inception, but one area in which evolution of Linux has seen fairly small acceptance, and because of that stayed mostly same for for large part of its history, with small but welcome improvements. That area is package management. While the introduction of package managers as we know them today is far improved than those from mid 1990s, which featured no remote repositories, no good dependency handling. Some of that can still be seen with dpackage and RPM, which can do much in regards to dependencies or use remote repos and require front-end applications like apt, DNF, yum, zipper, and similar to do so effectively. Improvements are on the horizon. Scratch that, they're already here. They are just not accepted for some, shall we say, reasons. What are those improvements? Containerized package managers, of course. Snaps, flatpaks, and similar. I'll mostly talk about flatpaks during this video as flatpaks are what I mostly use, but I'll mention others as well. So let's look at those reasons. Let's talk about how valid they are, and let's talk about what can be done to improve them. Starting with big guns. This one is the biggest criticism I've ever seen of flatpaks, snaps, and similar. They waste too much space, they waste too much memory, so on and so on and so on. So let's first get the easiest, even if in some cases wrong response. Price of fast storage is rapidly dropping. In most cases, we're not talking about 64 GB SSDs anymore, or dollars per gigabyte of yesteryear. Yes, there are devices that have low storage sizes and cannot be expanded, of course, but for those, you can still use other delivery methods that save space. Now, why does this larger storage usage happen? A package contains most, if not all, of its dependencies, which is a big departure from how dependencies are handled by things like apt, DNF, which install dependencies separately and are shared between all packages, which does lower storage space usage but at the cost of what has been in past referred to as dependency hell. Dependency hell is named for a set of problems that come from managing shared dependencies, some of which are long chains of dependencies, which thanks to modern package managers doing dependency resolution on their own doesn't really affect us much. Hand in hand with long dependency chains comes having large number of dependencies, which increases likelihood of having conflicts, or our third problem, which is our third problem. One is, in my opinion, today still a big problem with shared dependencies. Lastly, I want to quickly also mention circle dependency, which is when one package depends on another package in turn depends on a first package. So let's talk about dependency conflicts more in depth. In essence, dependency conflicts are when two packages depend on two separate versions of same package. Let's make an example. If you already have a package, let's call it P, installed, which depends on a library A of version 1. Now we want to install package R, which also among others also depends on library A, but with version 2. This doesn't work well in most cases. They either package R won't get installed, or it might just ask you, do you want to delete package P? Containerized package managers solve that by containerizing whole dependency tree, which helps us by separating dependencies, so package R therefore can't interfere with package P, but that does mean larger storage usage. Flatpak includes some storage replication and the ability to use runtimes. Essentially, runtimes are a set of libraries. Commonly, we see those used with, let's say, Qt, GTK, basically desktop applications, as those are most popular desktop frameworks and tend to be quite big. But many times you will see multiple versions of the same runtime installed, and runtime tends to be larger than what is actually required. Conclusion: is bloat a valid concern these days? In my opinion, in most cases, benefits outweigh the drawbacks, but there are exceptions, like if your device is fairly small and cannot be upgraded easily or at all. A substantial part of the list of complaints regarding containerized package managers is also the whole idea of sandboxing, which many such containerized packages come with, and therefore require a permission system to allow certain access. And I'm gonna say right out and say that permissions aren't at the level they should be. In many cases, complex to change and easy to overlook which permission package gets. At mention of being complex to change, someone may have actually did a double take and might have even said, "What about Flat Seal?" or maybe current efforts of KDE to integrate similar UI into KDE settings. But that's the catch. Those UIs aren't all that easy to navigate. Before before that you even need to know that they exist, and in some cases you might not even know what they do and how they may affect the application. On the other hand, let's make it clear: sandboxing, permission systems, containerization, all of these are important features of containerized package managers and provide important security. Therefore, we should not look down upon them. They, can they be improved? Of course, as far as I know, XDG portals do just that, but I can't say more than that on that front as I'm not that well versed in XDG portals. While a good chunk of performance issues and arguments could fit into the categories of sandboxing and containerization, I believe that this requires its own section to discuss, as much of it goes beyond just containerization caused it. So let's dig into this issue. First off, it's important to split the performance of the application and startup performance, as they have widely different answers whether they are actually an issue and need solved or can be solved for that matter. So let's begin with startup performance, which is especially problematic with snaps, but people have seen long startups with flatpaks as well. Largest part of increased startup time is unpacking and assembling the container file system. We're specifically talking about snaps. Additionally, while less impactful but can still contribute, is loading of dependencies for every package separately, unlike with contemporary model where some libraries need to be loaded in memory only once for usage by multiple applications. Now onto solutions for startup time. One can be preheating containers, like I do with my DistroBox containers, which just start asynchronously at login time, while Snaps already mounts quasi-fast file systems of snaps at boot time, but at first startup duplication, it still requires to decompress the file system, which can take some time depending on the size and how many files Snap package contains. Snaps use two different algorithms to ensure either small size at rest, so when it's just a file, when it's just a compressed file, or decrease the compression time. So to shorten the wait, snaps have to decompress during boot or install time. On other hand, Flexpaks don't have that problem as they are decompressed in install time, but but Flashback does have to establish a set of kernel namespaces and assemble some sort of overlay file system to combine random package in a writable layer, which, while doesn't take as long, can take a bit. Other part of performance equation is performance when application is running. Simply speaking, in most cases there should be very minimal to no noticeable impact, which can be different between different containerized package solutions. So let's focus on Flatpak, which uses bubble wrap as its container runtime, which in turn uses kernel namespaces, same kernel feature used by Docker OCI. Yes, kernel feature that allows certain kernel features like networking to be split into namespaces, but Flatpak also uses seccomp and capabilities. Seccomp is used to filter certain Linux syscalls, which can lower performance if those syscalls are used by the application. For example, some games can have performance drops due to certain syscalls used that are filtered by Flatpak's seccomp filter. But it's important to know that seccomp filter is necessary to ensure security and protect against easy sandbox escape. So a solve? Is there a solve for that? No, not really at this time. While there isn't as many people who complain about this, but Flatpak has a major focus on desktop applications, so a GUI application, and basically no support for CLI. While FlatHub accepts certain CLI applications, Flatpak itself does very little to tie them into your operating system and your path beyond creating a script that starts it starts it, but doesn't add it to path variables, so you have to do it yourself. But not all apps get added to the directory. Based on my experience, scripts for desktop apps don't appear in that directory, which means you can't just start your desktop app from terminal. There is a way to run any Flatpak app in terminal, but it's a long and convoluted command as it includes Flatpak run and a full FQDN of the app. You can see one on the screen right now, which gets annoying real quick. I'm not sure of the exact reason why they don't want to support it. So I'm not gonna speak to that, but even if I consider the part of modifying path variable, I do think that every app should be easily accessible from the terminal if you add just one path to path variable. 4 criticisms in, and this video is already